Hey, problem solvers, Colfax Math here. Today I was going to talk about the quadratic formula, what the quadratic formula is, how to solve quadratics, two different ways. One is factoring, and then the other is using the quadratic formula. And then I have 5 practice problems here. So I'll put a link to these in the description. You should print them out and then do them along with me. Maybe do the problem first, pause the video, and then watch me solve the problem. Make sure you're going in the right direction. Let me just talk about quadratics first. I'm going to put the camera over my shoulder and explain a few things, talk about solving quadratics, and then we'll get to these 5 problems. Make sure you have your notebook out and you're ready to take some notes and do some math, and let's get started. Okay, in algebra, a quadratic equation is any equation having the form where x is my independent variable, it represents an unknown, and a, b, and c represent known numbers. However, a cannot be equal to 0 for it to be a quadratic. If a is equal to 0, then this whole thing drops away, and it is no longer a quadratic. It is now a linear function. Quadratics are usually called second-degree equation, which means that the second degree is the highest degree. So it's a second degree because of the 2 right there. And these quadratics are all over the place. They are on almost all college standardized tests and some high school proficiency tests. So the first way to solve a quadratic is factoring. Let's say I have a quadratic, x squared plus 2x is equal to 0. By factoring, I'm going to pull out the common term and then use a zero-sum rule to figure out what the value of x is. So the common term is x. I pull that out front. I'm left with 1x here, and I pull an x out of this, and I'm left with a 2 there. The check of factoring out the common term is distribution. So x times x is x squared, x times 2 is 2x. Now I have these two things being multiplied together to equal 0. So that means either this has to equal 0, or this term right here, x plus 2, has to equal 0. So either one of those things would work to make the whole thing equal to 0. X plus 2 equals 0. I would subtract 2 from both sides to get x equals negative 2. So this quadratic right here, there are two solutions, 0 and or negative 2. That's a zero-sum property. I set it equal to 0 first. I factored enough so that I have things multiplied together to equal 0, and then those things, either one of them could or would be 0. After factoring, we go to the quadratic equation. The quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the fact that we have a plus or minus, this is going to give us our two solutions. So let's go back to our first equation, x squared plus 2x is equal to 0. Well, there's no value in front of that, so the a value would be 1, the b value would be 2, and there's no value here, so the c value would be 0. So I have a value of a value of b, and a value of c, and I plug those in here to solve for x. So x is equal to negative b. Well, b is 2, so negative 2, plus or minus the square root of b squared. There's my b. 2 squared is 4, minus 4 times a, 1, times c, 0. All divided by 2 times a. So let's simplify this a little bit. X is equal to negative 2. I'm actually only going to do the plus part here, plus the square root of 4 minus 0. So 4 all over 2. And then the negative part I'll do over here, or negative 2 minus the square root of 4 all over 2. Square root of 4 is plus or minus 2. So I'm going to have negative 2 plus 2 divided by 2. Negative 2 plus 2 is 0. Divided by 2 is 0. if it were 2 divided by 0, that's undefined, but 0 divided by any number is 0. So there's my one solution. And right here, my negative here, I have negative 2 minus 2 divided by 2. Negative 2 minus 2 is negative 4 divided by 2. Negative 4 divided by 2 is negative 2. So I come up with the same two solutions that I did before, 0 and negative 2. First way to solve a quadratic is factoring. Second way is to use the quadratic formula. Okay, I have 5 practice problems here. You could print these out from the link, and then I'm going to work through them again. Right now I'd pause the video, do the problem first, and then watch how I do it. Find two numbers that sum to 21. So they're different numbers, so that's going to be x plus y equals 21. And then the sum of the squares is 261. So the sum of the squares is equal to 261. I could actually just pick answers from the multiple choice and plug them in and see which ones work and eliminate ones that don't work. But let's go ahead and solve this with a quadratic. So if x plus y equals 21, I'm going to solve for x and then substitute it in there. So I'll subtract y from both sides. And I see that x is equal to 21 minus y. So I have 21 minus y quantity squared plus y squared equals 261. And then here, I'm going to need some more paper. What I'm going to do here is I'm going to FOIL this whole 21 minus y out. So I have 21 minus y quantity squared, which is 21 minus y times 21 minus y. 21 times 21 is equal to 441 minus 21y minus 21y plus y squared. So that first term is equal to that. Again, that's a FOIL, first, outer, inner, last. And then plus y squared equals 261. I'm going to combine similar terms, and I'm going to make it look like ax squared plus bx plus c. So I have one of these and another one of these, so I have two of them, 2y squared minus 42y plus 441 is equal to 261. I want to set it equal to 0 whether I'm going to use a quadratic formula or whether I'm going to factor. So I'll subtract 261 from both sides. And now I have 2y squared minus 42y is plus 180 is equal to 0. So now it's set equal to 0. I could factor out a 2 to start with. So I'm going to just pull a 2 out because it's common in all of them. Y squared minus 21y plus 90 equals 0. I could divide both sides by 2. Right? Divide both sides by 2. It'll still be 0 over here, but that'll cancel. Now I'm going to see if I could factor that. I'm looking for factors of 90 to give me a 21. So I have a y and a y. Those are only factors of y squared. Factors of 90 to give me a 21 would be a 45 and a 2. That's not going to work. A 15 and a 3. Well, now I have 15 and 6, and I could see 15 and 6 is going to give me a 90, right? So these are the multiples. So I have 15 and 6, factors of 90. Either they both have to be negative to give me that positive 90, or they both have to be positive. I look at this negative 21, and I see that they're going to have to both be negative. So this is negative, and this is negative. Again, the reverse of factoring is distribution. And in this case, I'm going to FOIL it out. I'm going to multiply my first together. Y times y is y squared minus 15y minus 6y gives me my negative 21y. And then the last term is negative 15 times negative 6, 90. So now I could use the zero-sum property. Either this equals 0 or this equals 0. So either y minus 15 is equal to 0, or y minus 6 is equal to 0. Adding 6 to both sides here, I get y is equal to 6. There's one solution. Adding 15 to both sides here, I get y is equal to 15. So I have two solutions to this problem, both 15 or x. Where'd the test go? So 15 or 6 are my two possible solutions, and here they are here. So number 1 is B. I could have also used the quadratic formula for this. I could have actually solved for y and then plug that in here. A lot of different ways to do it. This was just combining the two equations to get a single quadratic, setting that quadratic equal to 0, and then factoring. Okay, number 2, using the factoring method, solve the quadratic. 1x squared plus 4x plus 4 equals 0. It's already set equal to 0, so I don't need to do that. There's no common term in any of these, so I'm going to factor this into two quantities multiplied together to equal that. Factors of x squared are only x and x. Factors of 4 is a 4 and a 1, but I won't get a 4 with that, so it's got to be a 2 and a 2. Either they're both positive or both negative. So they're both going to have to be positive to give me that 4x in the middle. Again, the check is the first term is x squared, the outer term is 2x, the inner term is 2x to give me 4x, and the last term is 4. So I factor that correctly. Zero-sum property, this times this equals 0, means either x plus 2 equals 0 or x plus 2 equals 0. Same thing. Subtract 2 from both sides, and x is equal to negative 2. Number 3, I have x minus 31 over x is equal to 0. So that's x in the denominator. I need to get that x out of the denominator. So I'm going to multiply both sides of the equation by x. And then I got to distribute that x through here to get x squared minus 31 over x times x. My x cancels. Minus 31 is equal to 0. So I have x squared minus 31 equals 0. Let me move it up here. And I'm going to use the quadratic equation. So I have ax squared plus bx plus c equals 0. That's a general equation. So in this case, my a is equal to 1. My b, there is no bx term, so my b is equal to 0, and my c is equal to negative 31. Again, that quadratic equation is x equals negative b plus or minus b squared minus 4ac all over 2a. There it is, a little crowded. So that means x here is going to equal negative b, well that's 0, plus or minus the square root of b squared, 0 minus 4 times a times c, all divided by 2a, 2 times 1. So that's going to be equal to 0, or just plus or minus the square root of 0. Multiply these together. 4 times 1 is negative 4. Negative 4 times negative 31 is a positive. 62, 124 divided by 2. And that's a good solution there, plus or minus 124 over 2. Let's take a look at our multiple choice answers to see if anything's like that. There isn't anything like that, so we're going to have to simplify the radical a little bit. So to simplify the radical, we're looking at square root of 124. It's made up of a 62 and a 2. 62 is a 31 and a 2. For every pair, one comes out, right? For every pair 1 comes out, that 2 comes out. There's no pair for that 31, it stays in. So I have plus or minus 2 root 31 all over 2. My 2's will cancel, giving me plus or minus root 31. Let's see, those solutions are there. There it is right there, positive 31 and negative 31. So that's my solution to 3. Turning the page to number 4. Using the factoring method, solve the quadratic. This is 2x squared minus 3x equals 0. There is no c term. There's a common term in here. The only common term in there is x, so I'm pulling that x out, leaving me with a 2 and an x minus 3. Again, the check of factoring something out is distribution. So x times that 2x gives me 2x squared. X times that negative 3 gives me negative 3x. So I did that correctly. Zero-sum property is saying either this term is equal to 0 or this term right here is equal to 0. Solving this term right here for x, I add 3 to both sides, divide both sides by 2, and x is equal to 3/2, or as I look to the multiple choice, 1.5 in the decimal form. So I have 2 solutions, the 0 and the 1.5, and that's answer A right here. Okay, make sure you're pausing these videos and doing the problems first. Using the quadratic formula, solve this equation here. So I have 1x squared minus 9x plus 14 equals 0. That's already set equal to 0. There's really nothing common to factor out, so I can't really simplify it. So I'm going to go right to the quadratic formula. This is my a value, negative 9 my b, 14 my c. So x is going to equal negative b, negative 9, plus or minus b squared, negative 9 times negative 9, b squared minus 4, a, c, all divided by 2, a. Okay, so from there, let's simplify the square root. So x is equal to 9 plus or minus the square root of 81. 14 is 2856, and it's a negative. So negative 56, all divided by 2. 81 minus 56 is 25. So x is equal to 9 plus or minus the square root of 25 over 2. So this one right here, I'll just do the plus. And then right here, I'll do 9 minus the square root of 25 over 2. So this one we'll do there. Square root of 25 is 5. 9 plus 5, 14. Divided by 2 is 7. 9 minus 5, 4. Divided by 2 is 2. So I have 2 solutions, both a 7 and a 2. I'll look up here, and there's my answer, number 5, answer A. So there it is on the quadratic. Hopefully that helped you out. If you're new to this channel, think about subscribing. It's a practical math channel, and I'd love to hear your comments below. And if you liked the video, go ahead and hit like. Thank you.